many degrees it is without measuring it with a measuring tool, which is called a protractor, if you've seen protractors. And they have, and you can hold it there and you can see what degrees it is. You know, you hold it at the, where they, right there, and you put it there and then you can measure. But they don't give you those on a test. So they can't ask you what degree, the number of degrees in an angle, except the 90-degree angle, because they, if you see anything and just see the little box here, that little box lets you know that's a 90-degree angle. They don't have to tell you it's a 90-degree angle. But you can't just assume, ooh, that looks like it's a little bit more, so that's about 93. You can't make that assumption. You can't know what it is exactly, except that what you do know is that in every triangle, I don't care what kind of triangle it is, every triangle, when you add each of these degrees together, it equals how many? 9. Who knows? 9. Nope.
360.
180 degrees. That's something you need to remember. Now the way you can remember it is that if you undo this triangle, you'd have a straight line. And a straight line is 180 degrees. So every triangle has 180 degrees. So now they could tell you this was 85 and this one was 55 and ask you what's this one. How would you figure that out?
You said every triangle got 180 degrees.
Uh-huh. Add the ones you have and subtract it from 180, and that's what the third one has to be. Because they all have to add up to 180. So anytime they give you 2 of them, you can figure out the third one. Because it has to add up to 180 degrees. Okay?
So you add 85 and the 55 and then subtract from the 180.
Mm-hmm.
Okay.
Mm-hmm. If they only gave me this one and asked for those 2, you can't figure it unless they tell you the other 2 are exactly the same. You see what I mean? They'd have to tell you something. If they say, well, one is 85 and the other 2 are exactly the same, then I would do what? If I knew that these 2 are the same.
Take 85 from 180 and get what that is and then divide it by 2.
Exactly. See, if they told me that those were the same, I'd figure out how many more did I need to get to 180. That'd be 95. And if they're exactly the same, I'd just divide 95 by 2, and that's what each one of them would have to be. You see what I'm saying? Then I could figure it. But if they didn't tell me that, if they didn't tell me the other 2 are exactly the same, you could come up with all kind of combinations for 95. You could have 50 and 45. You could have 65 and 30. You know what I mean?
47.
You can't be exact. Yeah, 47, 58. You know, or for 48. So you could come up with all kind of combinations. So you can't be exactly sure unless they tell you something that lets you know what those other 2 have to be. They're exactly the same. Then you know you can just figure it out and divide it by 2. Otherwise, they have to give you 2 of them in order for you to figure out a third one. Now, they could have done this. And asked you for this one.
And not the other one.
But what is this one? 90.
Uh-huh.
Because they gave you that box. You see what I'm saying?
Yeah.
They could do that. They may not tell you it's 90, but when you see that box is there, you know that's 90. So they have given you 2. They gave me the 90 and they gave me the 45. You see, so be careful. 90 is the only one that they can have you not give it to you, but give it to you in a different way. They told you it's 90 because they put the box there. Okay? So look for that. But the main thing to know, when you see, anytime you have a question that deals with the angles of a triangle, what has to come into your mind is that they have to add up to 180. That is going to be the key. That 180 is what you're trying to get to. So that they give you, if they give you 2, you know what that other one has to be. Let's look at page 220. Let's look at 227. On 227, it shows you these angles. On 226, they show you that protractor that I kind of drew up there for you. That's the instrument used to measure the angles. And if you look there on 226, just going back, we need to talk about that too. There are different types of lines. You have parallel lines, you have perpendicular lines, vertical and horizontal. On that exercise 1, it shows you anytime you have 2 lines traveling in the same direction that will never cross, those are called parallel. For instance, Douglas and Kellogg run parallel to each other. Douglas will never cross Kellogg. I don't care how far you go. They're going to continue to run side by side. Okay, that's parallel. Perpendicular lines cross each other at 90-degree angle. So Douglas or Central and Grove are perpendicular. See, they don't run as a slant. This one runs this way and this one cuts it right there at a 90-degree angle. That's perpendicular. Okay? So lines A would be what? Parallel. B would be parallel. B as in boy. D as in dog would be perpendicular, you see. Now C, they intersect, but not at 90-degree angles, you see. They are not, it says, intersecting but not perpendicular. That number 1 answer there. They do intersect because they cross each other. That's why those things are called intersections, where streets cross. That's where lines intersect each other. Yes?
C would be like, almost like George Washington Boulevard and Harry, where it just kind of crosses.
Yeah, but they don't cross at a, right, at a 90-degree angle.
Right.
And then for those answers at the bottom, it says parallel, but neither vertical nor horizontal would be E. They run side by side, but they don't run. Horizontal would be the B ones, and vertical would be the A ones. Okay? You following?
Parallel is up and down.
Parallel doesn't matter. Parallel is that they run side by side.
Okay.
So A's are parallel, B's are parallel, so are E's. E's are parallel, but they're not horizontal or vertical. So with the answers at the bottom, it says intersecting but not perpendicular. We said those would be the C. Vertical and parallel would be what? What's vertical?
Up and down.
Vertical is up and down. Now sometimes people are not can't figure out which one, vertical or horizontal. So to me, when I tried to remember it, vertical because it has a T and T means tall. So that let me know that it was this way. You got to find all kind of ways to make yourself remember it, because horizontal, that don't say laying down. You know what I mean? There's nothing about that word that lets you know it's going this way. So I had to find a way. How am I going to remember which one's going this way and which one's going this way? So I looked at it and said, okay, there's a T in vertical and that's tall. So the vertical is up and down. See, you gotta find things like that to make yourself remember things. And so I knew the other one was horizontal. Okay? And so, let's go on. On page 227, it shows you the different, how they measure those degrees, and we talked about that some are acute, some are reflexive, and some are obtuse. You're not usually asked those questions on a test, but they may use those terms, and so I wanted you to have seen and heard those terms before. They may say the acute angle, and you just know that's just an angle less than 90 degrees. Okay, B, you see that little square there? For B, in the first row and the second, you see that lets us know that's a 90-degree angle, all the way down. And they will, except for the third one. And a lot of times they'll do that. They'll just put that little box there because they know that you're supposed to know. Universally, everybody has to know that when that box is there, it's 90 degrees. Because sometimes it'll look like that. It'll look like it's an L. But unless that box is there,
Don't do it.
don't say it's 90 degrees because you don't know unless you got a protractor. It could be just a little bit off. Your eye is not going to detect that. So they have to either tell you it's a 90-degree angle, or they'll have to tell you that it's a right angle. That's another thing they'll say, it's a right angle. If it's a right angle, you know it's 90 degrees. Those are things you need to remember, okay? Now, if it goes clear around, if the line starts here and goes there and keeps and comes on back around, what you have is a circle. And that is a whole 360 degrees.
Yep.
Now people will say all the time they did a 360. They don't mean they did a 360.